Okay, so the next question will be question number 10. Okay, if you look at this question, it says that two sinusoidal waves traveling in opposite direction interfere to produce a standing waves. They said they did give you the equation so that you can compare with the general equation. Okay, the question wanted to find the wavelength, frequency, and then speed. So first of all, you can compare with y equals to a. And obviously the sine and cos position can be interchanged. You can put the cos over there or sine over there as long as the x is with the cos and t with the sine. So that one will be k and that one will be omega. So here you can see that amplitude is equals to 1.5, but they didn't ask that, but they asked you to find the wavelength, which is inside the k. So k here is equal to 0.4 equals to 2 pi over lambda so if you calculate your lambda, you will get 2 pi divided by 0.4, which is 15.7. Okay, so the unit y and x in meters, so this one will be in meters as well. For the frequency, you can get inside the omega, where omega is equals to 2 pi f, right? So omega from the equation is equals to 200. So you relate this one with that one. And then 2 pi f is equals to 200. So yeah, f is equals to 200 divided by 2 pi. So here I got 31.8 hertz. Okay. And the last question, they ask you to find speed. V is equals to f lambda. So V is equals to 31.8 multiplied with the lambda. Got here is 499.26. Okay, it will be in SI unit as well, so meter per second. Okay, that one for question 10. For question 11, two waves in a long string are given by, okay. So the sign negative and positive indicates that these two actually move opposite to each other. So this one moves to the right, while this one actually moves to the left. So if they collide, you expect that the resulting will be y1 plus y2, right? And you learned before about the equation. If it combines, so straight away you can use the general equation of y equals to a sine. So this one becomes, because it's y1 plus y2, you can use 2a cos kx sine omega t. So this will be your a, this will be your omega, the one with the t is omega, and your k is actually equals to 1. So I can rewrite this equation, y equals to 2 multiplied 0.02 becomes 0.04 cos x is, sorry, k is 1, so cos x sine omega is 40, so it becomes 40t. First question, they want to find the position of nodes and antinodes. So if you want to find position of nodes and antinodes, you can use the position equation, which is cos. So it's basically the same question. So for the position of nodes, okay, so and I try to draw it for you guys first so that you can see clearly. So standing wave collide with each other, it will look something like this. Okay, you have up and down, up and down, up and down. The nodes represent this position when y is equals to 0. Okay, and this is the position of antinodes. Okay, so if you want to use equation cos kx, position of nodes will be when cos kx is equals to 0, while antinodes when cos kx is equals to 1. Okay, so this is the actual equation lah. So your cos k, which is equals to 1, so you can cos x equals to 0. So your x is equals to arc cos 0. You can try to press your calculator. If you use radian, you get answer in radian lah. So it will be apa ni? It will be pi over 2. Right. So pi over 2 is for the first position. So you have to add with another pi. So you can see that this one equivalent to 2 pi, right? So the position is actually something like this lah. So pi over 2 plus pi, which is equal to 3 pi over 2, plus another pi, which is equal to 5 pi over 2. So the numbers continues, okay? And so on, okay? The same thing happens over here. So cos x is equals to 1. So arc cos for 0, sorry, arc cos for 1 is equals to 0. So you start from you start with 0 and then pi and so on. Okay. So position of x will be 0 plus pi, 2 pi, 3 pi, and so on. Okay. And this will be in meter. And this will be in meter as well. Okay. So the position x will be in unit meter lah. So because you can read back over here where x are in meters and t in second. So I think just now I said it wrongly about the radian. Okay, B, the maximum displacement of an element in the string at x equals to 0.4. So when x is equals to 0.4, you want to find the maximum displacement of y, right? So you can use y equals to since they did give you x, so you have to use the x equation lah, which is 0.04 cos x. Okay, if they give you time, then you can substitute the time using 0.04 sine 40t. But they give you x, so you use this one. Okay, if they give you time, you use this one. If they give you position x, you use that one. Okay. I got here 0.037. Okay, again, make sure your calculator will be in radian. So it will be in meter. Okay, so again, the reason why you only substitute inside here is because we want to assume that this one is at maximum, and sine sine graph at maximum is when this one is equals to 1. So I'm going to write it down over here. So this one is when sine omega t, or sine, in your case sine 40t equals to 1. So this is when y is at maximum. Okay, so assume that one is 1, substitute x, and then you should get the answer. Again, don't forget to write down the unit. I think the last part is the comparison between progressive as stationary as well as definition for stationary. So I'm not going to read it for you. You can refer to this. Okay, maybe you can pause and you can read. So we already discussed in our tutorial, so I'm not going to repeat it. So thank you.